So this is just going to be a walkthrough of some of the typical types of ionic compounds, naming, and formula problems that we could be looking at, broken up into different categories. These are from the worksheet that we've done in class, as well as the worksheet that you'll be doing for homework. So the simplest type of ionic compound are called binary ionic compounds, which means that there are only two elements involved. Not just two atoms, but two elements. So for example, GAAS. The way you can tell how many elements there are is that each element has a capital letter. There might be a lowercase letter, but every capital letter means a different element. So in this case, there's two capital letters, which means that there are two elements, so it's a binary ionic compound. The naming of a binary ionic compound is you take the name of the first element, in this case it's gallium, and you don't do anything with that name. It just is what it is. It's gallium. The second element in this case is arsenic. And so we're going to change arsenic to arsenide. So when it's a simple compound like this, you take the name of the first element, which is always the positive, the metal, and then you take the name of the second element, but you change that ending from arsenic to arsenide or bromine to bromide and so on. Okay, here's again, we've got two capital letters, two elements. The first element, Na, is sodium, and then the second element is bromine, but when it's in an ionic compound, we change it to bromide. So sodium bromide. Two capital letters, two elements. The first element, K, stands for potassium. Now, the fact that there's a little 2 with the potassium in this case does not affect anything to do with the name. There will be times when you need to take a look at that, but those are only in certain cases. Most of the time, if it's a binary compound, you don't have anything to do with the little numbers down at the bottom. So the second element here, sulfur, S, so we change it to sulfide. Potassium sulfide. And here's another example. So two capital letters, aluminum is the first element, oxygen is the second element. Both of them have the little subscripts down at the bottom, but that doesn't affect the name. So we, again, always take the name of the first element, aluminum, and oxygen becomes oxide. So when you see oxide in a compound, it means just oxygen. So now we have the names and we need to come up with the formulas. So to remember the steps for the names, we need lithium and we need iodide. Well, lithium is in group 1, which means it's going to have a charge of +1. Iodine is in group 17, it's a halogen, it's going to have a charge of -1. Well, the +1 and the -1 cancel each other out, which means that the formula can just be Li, capital I. So lithium iodide is a 1-to-1 ratio because they have the same charge. Anytime they have the same charge to start with, you can just put one of each and they cancel out. Gallium chloride. Gallium is in group 13, which means its charge is +3. Chlorine, which is what chloride is in group 17, so it has a charge of -1. We don't have to write the minus when we're just writing the symbol, but just so you can see where the numbers are coming from. Now, in order to make this work, when we write the formula, we use the numbers to come up with the subscripts. So gallium, we need one of those, and in a formula, we don't need to write the one, so it's just Ga. And then chloride we're gonna need 3 of those, so that's where the number comes from, and we make that into a subscript. So GaCl3 would be the formula here. And what that means is you need 3 chlorines. Right, so gallium is +3. A chlorine is only -1, but then if I have 2 more chlorines, altogether they add up to -3, and that's why we have GaCl3. That gives me the -3 to go with the +3. Calcium bromide. Calcium is in group 2 +2 charge. Bromine, which is bromide, is in group 17, so it's going to have a charge of -1. So for every calcium, we need 2 bromines. All right, crisscross the numbers. So CaBr2, 2 bromines for every calcium. Aluminum sulfide. Aluminum is a +3. Sulfur is in group 16 with oxygen. It's going to be a -2. So if I have 2 aluminums, that gives me a total of +6. If I have 3 sulfurs, that gives me a total charge of -6. So the 3 times the 2 gives me 6. The 2 times the 3 gives me 6. And this is why you always, the simplest thing to do is always just reverse the numbers. So take the number from the first element and make it into the subscript of the second element. Take the number from the second element and make it into the subscript of the first element. You'll always get a neutral charge.